Physical Sciences, grade 11 and grade 12. I welcome you to today's lesson. We are continuing looking at Newton's second law's problems. Remember, previously we solved one of the problem where we were required to calculate the tension on the string which was between the two blocks. So today we are going to answer the second question. You can see that the diagram is on the screen already. We have two blocks or two boxes. One is on the table and the other one is hanging and then is attached to a string which is also connected to a 20 kg block. You can see that we have T1 and T2. That's the tension. So let me read. In the diagram above, the frictional force between the 20 kg and the table is 10 Newton. We are given the frictional force between this block and the table, and that frictional force is 10 Newton. So the first question requires us to determine the acceleration of the system. We are required to calculate the acceleration of the system. So how do we do this? The way you work out this one is the same as the way we have done the calculation under the first problem. What do I mean when I say it's the same? In this one, we will do some work on the 20 kg box and also do some work on the 10 kg block or box. And then we'll combine the two work, and this will lead us to being able to determine the acceleration. Let's first do some work on the 20 kg box. Or before we go there, remember there's an issue of direction. To the right, positive, to the left, negative. So in this one, in a problem of this fashion or form, let's look at how we decide on the direction. Let's see how this, let's see the movement of this object. How is it moving? You can see that we have the horizontal motion and the vertical motion. Unlike in the previous example where the motion was only horizontal, this time we have horizontal and vertical. So if I'm moving in this way, if I'm following the string here, see what I'm doing? I can talk about clockwise. Clockwise. This is how the watch moves clockwise. If I'm opposing what I've just done, moving like this, is anti-clockwise. Anti-clockwise, clockwise. Then we are going to decide on the direction based on what I've just done. Take the clockwise direction as positive. Take the clockwise direction as positive. which means that anti-clockwise will be negative. For 20 kg and 10 kg, we will take the clockwise direction as positive. Now, let's do some work on the 20 kg first. We'll draw the free body diagram of the horizontal forces that are acting on 20 kg block. We have T1, which is pointing to the right, and the frictional force, which is pointing to the left. Here they are. This is T1, this is FF. We already know the direction that clockwise is positive, anti-clockwise is negative. This means that my T will be positive and my FF will be negative. What do we do next? We bring in F net equals to MA. What makes up F net is T and FF. T as positive and FF as negative equals to MA. Next step, do we know the value of FF? Yes, we're given. It's 10 Newton. Do we know the mass? Yes, mass is 20. But we don't have T and A. Because we're looking for T, we make T subject of the formula. At the end, we have T equals to 20A plus 10. Because we have two variables, this becomes our equation 1. Then we go to the next block, which is the 10 kg block. You see, the 10 kg block here, forces that are acting on this block. We don't have F normal here. We have F normal on the object which is resting on the surface, but this one is hanging. So we have only two forces that are acting on this box. We have FG, which is pointing vertical downwards, and we have T2. T2 is pointing up. So here are the forces that are acting on a 10 kg block, FG or MG, and T2. T2 pointing up, and then FG pointing down. Remember, if I bring that issue of clockwise and anti-clockwise from T1, see T1, clockwise, my FG, if I'm following the clockwise motion, my FG will be positive, and this T will be negative if I'm following the anti-clockwise. So my T is negative, my FG is positive, equals to MA after introducing the F net equals to MA. Minus T plus this FG is the same as MG. I don't have the value of FG. But if I change it to MG, because they're equal, I can do the substitution here because I know the mass. My mass is 10 and G is 9,8. Again, here I'll substitute M by 10 times A. Now I have T and A here. I must make T a subject of the formula. At the end, this is what I get, 98 minus 10A. This becomes my equation 2. Now you have equation 1 and equation 2, and they both equals to T. So we equate equation 1 and equation 2. Here I've put equation 1 equals to equation 2. All these contain variable A. Then we solve for A. We solve for A here. At the end, A equals to 2,93 meter per second square. This is the acceleration of the system. So let's look at B. Draw all the forces acting on the 20 kg block, not only horizontal, not only vertical, but all forces acting on the 20 kg block. T1, we already know this one. And remember now, here they are not saying free body. Draw all forces acting on the 20 kg block. It means that you draw force diagram, not free body. That's why I just put a box here. If it was a free body diagram, I was going to put a dot here and indicate the forces around that dot. But they're saying that a force diagram, 20 kg, T1, and then FF, F normal, and FG. These are all the forces that are acting on the 20 kg block. Let's look at C. C says that calculate the magnitudes of T1 and T2. We want the magnitude of T1 and T2. Before we do this calculation, the tension in the string must be the same. The tension must be the same, meaning that T1 must be equal to T2 because this is the same string. So the tension must be the same. When doing this calculation, we must put this, or we must keep on reminding ourselves that the tension in the string is the same. How do I calculate the tension? Remember, I have two equations here, equation 1 and equation 2, all of them equal to T. It means that I can use equation 2 or equation 1 to get the tension. Let's do it here. I've chosen to use equation 1. I've chosen to use equation 1. What do we do here? Here's the equation 1. We already know the value of A, which is 2,93. We have calculated it in A. So what we have to do here is to substitute. Where there is A, I'll put 2,93. And if we use our calculator, at the end, the tension will be 68,6 Newton. You can see that I wrote that T1 and T2 have the same magnitude.